Good afternoon, my name is Chris and it's my privilege to welcome you to this, the very first broadcast for a brand new initiative called Women in TechWorks. The core mission of TechWorks itself is to ensure the UK tech sector performs on a global stage, ensuring it maintains relevance and is seen as a leader. TechWorks is the parent organisation of several deep tech connected communities. There's the NMI, there's ASIN, there's Design, there's TechWorks-AI, and there's the IoT Security Foundation. The industry is largely male, so Women in TechWorks is our programme to raise awareness, promote, celebrate, and accelerate women's careers across our connected communities in semiconductors, embedded systems, cybersecurity, AI, and automotive. So to achieve this, we've got a strong steering group committed to driving initiatives in the talent pipeline, leadership pathways, mentoring, and raising awareness of the sector and our talent. Not all the roles are technical, but every specialist role matters. We'll leverage experienced stakeholders, that's women and men, technical and non-technical, to drive success. So Women in TechWorks launches officially on the 30th of October in London, but today we're showcasing the talent already here. We intend to make these Women in TechWorks broadcasts a regular occurrence, and we launch this series today with Rasadhi Attale, who is Senior Hardware Engineer at Siemens. She'll be sharing insights on scalable verification for systems on chip, managing complexity at scale. Ras brings a wealth of experience, having previously contributed to the verification team at ARM, specifically on Cortex-A processors. And in addition to her current role at Siemens, she's also pursuing a master's in cybersecurity at Oxford. So this lady is not messing around. She knows her stuff. For those watching this broadcast live, if you have any questions, comments, or observations on what you're about to see, please put them in Zoom chat. And well, I'll put those to Ras following her presentation. If you're watching on YouTube, please like this video and subscribe to our channel. It helps us more than you know. So we now cross over to Cambridge. Ras, my friend, the floor is yours.
Thank you, Chris. I'm just going to share my screen. So as Chris mentioned, we're talking about scalable verification for SoCs. So the agenda for today is we're going to take a look at what test versus verification is, some of the verification challenges you have in complex designs, and the components that a scalable verification framework would encompass. We'll have a look at a verification execution flow and the verification flow that I use in our team here, and then we'll talk about metric-driven verification. So to start off with, test versus verification, the age-old question. So what is test? Test is mainly looking at physical problems of a chip that has happened during production. So the scope is to look at the chip after the fabrication. And to find physical issues. But verification has a broader scope. It is executed throughout the design phase, both front end and back end. And the main goal of it is to ensure that the design is implemented correctly according to the specification. So let's take a look at some of the verification challenges we have with complex designs. So if we look at design-related challenges, one of the main things is the designs these days are really complicated. They have over 10+ billion transistors, which are all integrating and causing a lot of complex issues. This leads to a very large verification state space because each module causes an exponential growth in the verification state space. And they normally consist of multiple interfaces like Ethernet, USB, JTAG. And as a verification engineer or in verification, you need to ensure all of these interfaces are protocol compliant. So that means it adheres to the protocol specifications that set out. And most of these designs, or almost all of them, would have multiple clocks. Now, this brings in cross-domain complexities. The cross-domain is when a transaction or an event will cross from one clock domain to the other. This brings in delays and sometimes functionality changes. And all of this, we still need to ensure that it meets the timing spec that is set out. So these are some of the design-related challenges we have. And there are some environmental challenges as well that verification engineers face. One thing is slow simulations. It limits the state space that we can cover, the coverage that is there, and we also have limited computing resources. Unfortunately, we don't have unlimited resources to use all the time. And another challenge we have is sometimes we have legacy systems, old test benches that either needs to be maintained or upgraded to be used for new methodologies. And then the biggest question, the age-old question of when is verification complete is also there. And we face timing issues, time to market pressure, and also we have staffing challenges, not just in the lack of verification engineers, but also the knowledge that is shared, the gaps of knowledge. So it's really important, quite key, when you're testing a scalable IP, that there is a robust and efficient verification environment where quality can be measured. So with that in mind, let's look at scalable verification framework. So one of the a scalable verification framework, one of the underlining rules is it is a hierarchical based approach. So that means it will have a block level verification. And what this does is it breaks down the complex design into smaller chunks. So it reduces the verification state space significantly for the engineers that are using it. And then you build on this, you do block level, and then you would increase it, you would add on a subsystem layer to test it, and then you would have a system level verification. Now, all of these, one of the other components that's quite key is something called common components or reusable IPs. They be common components, some virtual interfaces, BFMs. What they do is it reduces the verification time when in helping you to use it, because it's already written once, but because it is verified and tested over time, they are quite mature IP, and the confidence actually is quite high. And other components of scalable verification IP is scoreboards and checkers to understand the behavior of the design, and also coverage to provide some numbers and matrices. Now, all of this needs to go into frequent regressions, because that's the way you could monitor the health of your design or of your block level, subsystem, and system level. With regard to regressions, the block level ones would need to run on a nightly basis, because that way any issues can be found quite early on. Subsystem and system level can actually run when design changes are made. So it kicks off the regression, and that kind of ensures that any design changes doesn't necessarily impact overall, doesn't have overall implications. And they all fit under what you call a verification readiness strategy. That would have tools such as checklists and release IP notes to help a verification engineer to understand the verification progress and when an IP is ready to be released. And all of them sits under metric-driven verification. Now, I'll talk a bit more about it later on. So if you look at a verification flow, we have specification, which is written by design engineers. So the specifications will feed into the verification plan. And based on the verification plan, it will feed into test bench, as well as inputs from the RTL design will go into the test bench. And then from the test bench, which has a stimulus to generate all the transactions and different kinds of scenarios, you will have the DUT, which is the design on the unit. design unit under test, sorry, assertions like property assertions or interface checking, then also some checkers, and you'll also have coverage, which is some matrices, that numbers that you would gather. And this all goes into the verification execution, and there are different models and methods that you can use. You can use PSS, which is portable stimulus, UVM methodology, VIP, and all of that will then feed into the verification management that goes into verification planning, and will keep looping back until verification is complete. So an example verification flow that we have with some of the tools that I use with our team in Siemens EDA is Polarian. We use this for to hold our specifications. Our specifications are live documents that will live under Polarian, and Polarian actually has the capability then from the specification to create something called requirements or work items that highlights what features and needs to be tested and verified. And our test plans, which is our verification planning, sits in a tool called the Verification IQ or VIQ. And the VIQ will have the test plans as well as our coverage database as well. And it's a tool with quite a few different packages like the coverage and dashboards. And we will use formal as well as constrained random stimulation to do our verification. And both of them, we will have coverage that we collect from both, and then we merge this coverage, which also sits in a VIQ, and then feeds into a dashboard for us to understand. So I will talk a bit more about the merge coverage and dashboards later on. So let's look at metric-driven verification. So some of the benefits that we actually get from metric-driven verification is it helps you to quantify the verification state, because you are able to provide data, you're able to provide numbers to quantify it, which makes it a lot easier to understand where in the verification timeline you are, the progress of it, and also makes the completion criteria clear. And it addresses the aged-over verification challenge: when is verification complete? One of the other key things is it helps you to identify bugs early on, because you're looking at the bug rates. We use Jira to monitor our bug rate curve, and also dashboards to understand our regression health. So it's which helps us to identify these bugs early on in the design process and help us to eliminate them. Another thing is it helps us to identify any gaps that we have through coverage, and also through test plan versus specification. We will be able to understand if our verification planning is complete or not with regard to the specs. It also helps us to understand what coverage holes do we have, and help us to increase the health of our stimulus and complete verification. Because of all of them, it provides a very high confidence in the code that you are producing. And this leads to having better customer relationships, because you're able to provide quantifiable evidence of the verification you have done. And another big benefit is because you actually am able to identify the verification resources and the effort that you have, you are able to give it a better confidence, the timelines, and be able to deliver this on a timely manner. So some of the key components of a metric-driven verification is having test plans which have a traceability to the specification. And I'll talk a bit later. And the other is real-time and interactive dashboards. I'll talk both of these points later on and explain what I mean and how it works. And then some of the tools that we use to help with this is, as I mentioned, Polarian. We use for our spec maintenance and requirements. And then we use VIQ for our main verification management and reporting. It has all the test planning, regression, and coverage databases, dashboards as I mentioned. So let's look at specification versus test plan. What exactly is a specification? This is a document that is written in like a natural language to describe how a component or a design would function. So this is mainly written by the designer and would give an understanding of how the design is meant to be uh, implemented. And then what the test plan does is it provides the verification engineer. The test plan is something that the verification engineer has to develop, and it helps to give a link between what we are testing and the coverage numbers that we gain versus the specification. So, for example, in this example, we are saying lorem ipsum is a dummy text that is used for printing and typesetting industry. It also says that it has been there since 1500, and also that it has not only survived 5 centuries, but it's also used in electronic typesetting. So on this, in this scenario, the fact that this is that this dummy text is used in printing and typesetting is one requirement of this dummy text. The fact that it has been there since 1500s is another key important fact about it. The fact that it has survived 5 centuries is also important, and also the fact that it's being used now in electronic typesetting. So then Polarian extracts this as requirements. And then what we do is we will raise on the verification side, on the test plan, we would say, okay, we need to verify that this text is used in this printing and typesetting industry. It has been there since 1500s. It has survived 5 centuries. So it provides a link between the specification and the test plan and mapping it. So this is very, very important. And this is one of the key things in metric driven, because without mapping the specification to the test plan, we would not know whether our verification efforts are complete. So if you look at, as I mentioned, the verification test plan, this is the start. So any verification process, the start is the test plan. You would get the specification, you would write down all the key points that you would actually, is important for you to verify. It's quite vital that you get this process correct, because if you don't get it correct, there'll be gaps and you have to keep going back and completing it or modifying it. And then if you collect and you'll be collecting coverage based on it, so we'll have to redo your coverage and some coverage may not be useful. So it's very important to get this step right. And so I can show you one of the things we do with our tool is we have, so as you can see on this screenshot, we've got, this is from our test plan, and we've listed our IP is highly parameterized. So it's important for us that we test all our parameters. So we have a parameter that is set in the test plan, and we say, okay, we want to ensure that we have tested, we have seen all values for our index length P in our stimulus. And this links to, and we provide a link to our specification in Polarian, which will say it is from this work item in the Polarian test plan for this module. If you look at on the right-hand side, so as you can see, we've got parameters, and it says one of the parameters is index strip, and then that's linked, that has its own work item called 1.7 in Polarian, and then that is linked to our VIQ. So that provides traceability from our test plan to the specification and back, which is quite important. And another thing that provides is, as I mentioned, metric-driven verification is based on different matrices. So requirement-driven verification, the Polarian is able to then, based on this, map out all the requirements for that specification we have mentioned. In Polarian, a requirement is basically a work item. So they have some work items that we use. We have two of the different work items. We have requirements and test cases that we have picked, but you can actually customize your work items to be whatever you would like it to be. So we will have these requirements, and then it will also show which test plan point covers this requirement and the coverage for that test plan. So this provides a very easy pie chart that to help us understand the gap. So you can see there's a certain percentage of the pie chart where the test plan has not been linked, and also where a certain percentage where coverage hasn't been complete. So it's very easy to understand the gaps and manage our resources and our verification efforts accordingly. Another one is reusable test plan. So I mentioned one of the components of a scalable verification framework are common components. And so test plans, so all of these common components and interfaces that we have has to have their own test plan. However, while they are being verified in each module and they become a mature IP, if you duplicate the test plan for each module or each IP that you have, each block level or subsystem level test plan that you create, it is duplication. It takes up a lot of engineering time, and it doesn't provide help. So we have what we call reusable test plans that we have in. So message IF is a common component that we use. We have its own test plan in VIQ, like any other block level test plan. And what we do is on each of our blocks, we will then reference this test plan and make sure that when in our verification of the block level that we cover all of these items from a block point as well. So that's one of the benefits of having reusable test plans. Then we take a look at, so I'm coming into dashboards. So before we look at real-time dashboards, if we look at the challenges of not having one, I'm sure all of us, or many of us, would have been at a point where we've had to provide a verification status report, and then you have to understand and provide some form of quantifiable numbers. But if it's not a real-time dashboard, it will have to be a manual process, and it can be time consuming to generate these reports. And it also, it's a very reactive process rather than a proactive one, because it's a snapshot from the past, and what the bugs and the pass rates or any kind of code coverage would have happened in the past, and it's not something that is happening right now. And also, there's a delay in providing this insight. It's not something you won't be able to change a design, change something in a design and see instantly the impact it would have, even if you have verified it locally. Sometimes there are design changes that impacts the design, a module level design change that impacts the overall design. So these are some of the challenges you have. So if based on that, the benefits are with these interactive and real-time dashboards is you get an immediate visibility of the verification progress that you're making. It also, you get trend analysis details, and you can find out quite early on the bugs that you would be able to detect, because if once you what would happen is we use Jenkins as a scheduler, and we run our regressions on Jenkins, and then the regression results at the end of the regression will get ported to VIQ tool for us, and it will provide us with all the details of that regression, and we can drill down into it. So it provides us a platform to do data-driven decision making. So I'll show you a couple of examples of this. So this is one of the dashboards that we have. It provides an overall health for a module. It shows us what the coverage summary is, how much branch coverage, how much statement coverage we do. It also provides the coverage trends for us, provides us functional versus code coverage trends, and the number of tests that has passed through the regression, and also So those are some of the things that you would find overall. So then we are looking at something called a regression analyzer, which is another part that, so this is where all the details from a regression would come in immediately. So you would know, okay, so we had 222 tests. Out of that, 217 passed and 3 failed. So you know at a glance, okay, we've got 3 tests failing, but we don't have anything that is pending or still running, which is good news. So no tests have timed out. Then you say, okay, I have a total coverage that's from the UCDBs that have been collected. And then you can see out of that, the test plan coverage. So the test plan coverage can be lower than the total coverage because not all total coverage could have been mapped to the test plan coverage. And then you would say, okay, this is the latest run that I had, and these are the stats for it. This is the SHA that the Git SHA that was used, so you know exactly which version of your code was used. It will also give you your failing signature. So, and it will tell you when was the last time that failing signature occurred. So it's a very good way to understand if you see a new error, or if you see a new error message, be like, okay, this is a new failure. And also it gives you the trend, so you can zoom in to understand for like last 2 weeks or last week or just a couple of days. So it's not always you need to see the entire data range. You can actually customize it to the way you want to see it, and it's very easy to understand looking at the test trends. It's very easy to detect if something has gone wrong in your design because your pass rates would go down. And then if you look at, this is looking at coverage analyzer. So all the coverage that we gather from our regressions also live in VIQ in a database. So this provides us an overall coverage of our module for that, and also gives a breakdown of how much of that is belonging to like statements and branches. It also shows this red is the excluded coverage that is there. So it gives you a heat map of what is being covered and what is not. And then you can click on this red heat map and it will take you to the bit of the code where it has not been covered. So it's very, very easy to understand your gaps and kind of fine tune your stimulus to increase the health of your stimulus. That's quite important. And another thing that it actually does help is it helps us with resource optimizing. It actually shows how much of our regression time versus our CPU time is there. So as you can see, sometimes it goes high. So we are then able to understand, okay, our regression time is greater. So this helps to manage the resources we have. And if you can remember, one of the challenges we had with verification was limited computing resources. So this is quite helpful to overcome that. Now let's look at coverage, which is also very key for a scalable IP to have coverage that is collected. And when we talk about coverage, it's both functional and code coverage you need to do. And I mentioned that we use a tool called Jenkins to run our regressions and collect the coverage that we have. And because our IP is parameterized, we use a waiver system to help us to understand our gaps. So some of the gaps that we would have, because it's parameterized, we will not be able to cover those conditions based some statements or branches or some code or functional coverage based on the conditions we are running our test in for that, or the configuration that we are running our test in. So these we put under green as unreachable under these conditions. So we call them as green waivers. But the most important ones we focus on these red ones, where these ones have not been covered, but they should be covered. So this helps us once again to manage our verification resources and our efforts, because we will not then waste our time looking at unreachable code, but we put our focus in ensuring that we have completed our amber and red waivers. And we also work on merged coverage. So we have, what we do is we use the union merging strategy, and we run regressions with different configurations because our IP is parameterized. And then we merge all of this different use coverage that we gather into what we call an accumulated UCDB. And then we send that off to BIQ, where our accumulated UCDB coverage sits with a database of the metadata. So coming back to how we map it all, so we said I showed you specification versus test plan, but the coverage, how it maps back. So we've identified the requirements, we put it in, we linked it on the test plan. So then we link the coverage from the test plan as well and say, okay, for the first test plan item, we are covering it with a cover group from the functional coverage. Also, we have some branch coverage that also helps us to cover the test plan point, first test plan point, which maps into the first requirement. So this is a way for us to then, once it is completely mapped and covered, for us to go, okay, we are confident that our verification efforts have been successful and we can close complete verification and close coverage. That's all. Thank you very much. If you have any questions, let me know.
Thank you very much indeed, Res. We'll start putting some questions to you in the next couple of moments. Just got a couple of things to get through first. I'm going to talk about some TechWorks events which are coming up in the very near future. The first one is from our Design Connected community, and that is on the 10th of September in Reading. It's an FPGA Frontrunners event, and it's themed Building Resilient and Cybersecure FPGA Systems in an Adversarial World. Then in October, on October the 30th to be specific, it's the joint IOTSF and TechWorks-AI conference, where the official Women in TechWorks is going to be launched, and that's going to be taking place in London. There's also the Design Conference, which is on the 6th of November, again in London. And then on December the 3rd, it's the big one, where all of the connector communities come together. It's the 2025 TechWorks Awards and Gala dinner in London, and it's a very posh black tie event of the year. If you're watching this broadcast live, I'll put all of the links in just a moment for those events in Zoom chat, and if you're watching on YouTube, I'll put the links in the description below. But now on to the Q&A. Raz, I'll get you to stop sharing your screen if that's
sure.
all right.
Yeah, sorry.
That's all right, don't worry about it, and I will put myself on screen properly. Just give me a second to fiddle about. There we go, that looks the part. Right, first question on Zoom chat comes from Gareth. How does the test plan account for things like DUT temperature and voltage variations, and how is this verified in practice? That is, how is it verified that the functionality is verified for all temperatures and/or voltages, etc.?
So temperature and voltage isn't functional verification. That would go under, that's post-silicon. I don't have any experience in temperature and voltage verification because I work on soft IP, but that would very much be something that you would test after the silicon has been fabricated. At least that's my understanding.
Okay, thanks for that question, Gareth. Katrina, she says, first of all, thanks for a great presentation. Do you have any advice for testing chiplets, particularly around how to divide up a test plan?
Oh, good question. How to divide up a test plan. So I would say, even in a chiplet, once again, I would take up the same approach as a hierarchical one and break that into small blocks, because a chiplet has different components. And if you try to verify it as one, it's going to be complicated, just like what we face. So I would start off with a block and then build up to a subsystem and a system level. That would be my advice.
All right, thank you very much for that. I hope I'm pronouncing this next name correctly. I think it's Oana. Thank you so much for the amazing presentation, Raz. It's gone down very well, apparently. I was just wondering how flexible this flow is to changes in the specification. Is it possible to maintain multiple different versions of the same modules simultaneously?
It is. So that's a very good question. Thanks, Alana. We do have different variants for our modules that we test because they have different IPs. From a specification point, we have only one spec for it. So you can't have multiple specification for the same variant because how our specs would work is we write all different variants into one spec. But from a test plan point, we have various, we break our modules down to different variants, and each one will have its own test plan, will have its own regression, and have its own coverage for that variant. So it is very easy to have multiple variants of the same IP.
All right, thank you very much for that question, Oana. In the specifications versus test plan versus coverage, is the verification engineer responsible for preparing all of that?
Very good question, Chris. Actually, no. The design engineer is responsible for preparing the specification, and the verification engineer is responsible for preparing the test plan and ensuring that the appropriate coverage is done. So it's a split effort.
Okay, thank you. Now, I've heard that the RTL and verification engineers should not actively collaborate because that creates some kind of bias. Is that true? And what would the bias be?
That is true. Because this is why the specification is written by the design engineer. The reason to ensure that you don't have cross collaboration is to ensure a degree of independence. When you're looking at the same spec, this is the best way to ensure that you implement it independently and find bugs. Because if you talk and you collaborate very well, your thinking is going to be the same, and your implementation is going to be the same. Hence, you're not going to find bugs. But two people implementing the same thing, reading off a document, has a higher chance of finding anomalies in the implementation.
Okay, thanks for that. Are we limited to the widgets shown in the presentation for VIQ or not?
No, actually, we are not. They are customizable, so you can have as many different widgets as you want. They are customizable widgets. We created the widgets that we wanted.
All right, fantastic. Someone who doesn't know much about verification, what would be the major benefit of using UVM? Why does the verification industry rely so heavily on this library stroke methodology?
So, very, very good question. So why UVM is mainly because I remember I mentioned there were some verification challenges we have, what was staffing and to do with basically and knowledge, right? And in the scalable verification, we use common components to ensure that we have less effort, less duplication of work. So UVM allows us to do this plug and play reusable components where it helps us to verify things a lot faster. And also one of the other main things is knowledge sharing. UVM is not company specific. It is used universally. It is used among all companies. So if you have an issue, you can ask the UVM community to help you fix the problem because it could be something, the knowledge is out there. There's enough people to help you. So there's a lot of knowledge sharing. And this is one of the main benefits as well of using UVM and why industry is keen in using it.
All right,
It helps
lovely.
to
Thank you.
streamline the verification process.
Nice one. This question is from Gunny. In my experience, there are often discrepancies or ambiguities in specifications. Would that necessitate dialogue between design and test engineers? That is always a risk.
So basically, it doesn't always necessitate a risk, in my opinion. If something is not clear, if you ask for clarification, that helps the designer to think of things that have not been, and those discrepancies could also come up as a bug. So when you have a bug and you show evidence of a waveform and your implementation, and then there'll be an intelligent discussion as to why you think your implementation could be right, or they say so. It would be more of a technical debate as opposed to going, or how does this particular functionality work? So then the risk is less because we both read, we have different understanding. So then we kind of not debate, but we discuss technically why we think our interpretation is right or what could be missing, and that provides less bias as opposed to just going and asking the design engineer, "Could you explain to me how this works?" Which is what I was mentioning about the unbiasedness.
All right, lovely. Thank you very much. That's just about it from us today. As I mentioned previously, there's several TechWorks events coming up in the near future. If you're watching this live, I've put all the links for them in Zoom chat. And if you're watching this recording on YouTube, we'll put the links in the description below. They are from Design on the 10th of September in Reading. That's the FPGA Frontrunners event, building resilient and cybersecure FPGA systems in an adversarial world. Then on October the 30th, it's the joint IOTSF and TechWorks-AI conference, where the official launch of Women in TechWorks is going to take place. That one's in London. Then we've got the Design Conference on the 6th of November in London. And then on December the 3rd, it's the big posh black tie event of the year, the TechWorks Awards and Gala dinner. Nominations for all of the awards categories, by the way, are currently open. There's also on the 18th of September, the QEPNT event at ZF as well, which I've just been asked to mention. So today's broadcast was the first of a series from the Women in TechWorks initiative. Look out for details of the next webinar very soon. And in general, we'll be making a lot of noise about Women in TechWorks over the coming weeks, months, and years. My thanks again to our special guest today, Raz, and we'll see you again soon. Enjoy what's left of the summer. Bye for now.